lot of the A-level syllabus seems to be about these two things, integration and differentiation. And I think for me, what makes mathematics somehow palatable is to understand, well, why are these things so important? Where did they come from? Why do we need to invent differentiation and integration? And in fact, these two tools turned out to be some of the most powerful things that are used across the sciences. So take differentiation, for example. You've probably learned all these rules to be able to do those exam questions, but what was it all about? And I think it's key to remember that differentiation actually was essential to understanding a world in motion. So things are constantly changing. If I'm in my car and I put my foot on the gas, I'm accelerating away. How can I say what my speed is at any particular time? Well, you can measure the distance I've traveled divided by the time, but that's just an average speed. So what mathematicians came up with was a tool to be able to say at any particular instant of time what that speed is. So in fact, you're taking the interval of time smaller and smaller and smaller until actually you're calculating zero distance divided by zero time. But Newton and Leibniz, who developed differentiation and the calculus, were able to make sense of what that means. And so differentiation was really the tool to understanding a world in motion, absolutely key to the world of science. And integration? Well, actually, that goes back a long way, because even the Egyptians, in some of the papyri that they wrote, a very early form of integration is there. Because if you think about it, integration is trying to understand volumes of solids or areas under curves. And a key thing actually in doing mathematics is how can you make something complicated into something much simpler that you understand? Actually, I think that's probably key to the exam questions you're going to answer. If it looks complicated, try and break it down into simpler things. And that's what integration was about. What the Egyptians discovered, for example, was if you want to calculate the volume of a pyramid, well, how do you do that? Well, if you cut it up into pieces and approximate those pieces by just rectangular boxes, then, well, the volume of a rectangular box is easy. And you just make those rectangular boxes smaller and smaller and smaller until they're infinitesimally small, and then suddenly you get a formula for the volume of a pyramid. And that's actually what integration is just about. It's about finding ways to approximate a question by things that you already understand. And actually, that's at the heart of what mathematics is about, building a pyramid. And that's what you've been doing over the years at school. You've been building the layers of your mathematical pyramid, things that you understand, and you build on top of those to make things more and more complicated. And you're reaching a high point on that pyramid. But there are exciting things beyond just A-level, and I hope many of you will, this will just be just another layer on a journey that will perhaps end up proving some of the great unsolved problems of my subject.